Greetings from high above Grand Park overlooking scenic Westfield. It's my solution to question 8.21. Well guys, I assume you recognize this question. This involves our 20 athletes with an 80% graduation rate. So this value x, this count x, is distributed binomially, 20 trials, success probability of 0.8. So here are the formulas for the mean and for the standard deviation of this count, or this random variable, this binomial random variable. N times p, 20 times 0.8 gives you 16. There's the mean for part A. And for part B, the standard deviation is the square root of the quantity count times success probability times 1 minus the success probability. So that's just the probability of failure. So that's the square root of 20 times 0.8 times 0.2. That's about 1.8. So what that tells us, we expect a count of about 16 athletes to graduate. And the standard deviation gives us an idea of typically how much we may expect to vary from that 16. We could be up or down 1.8, 2-ish athletes, if you will, when it comes to graduation. So part C of the question then I think is pretty interesting. Let's skip over to the calculator. So what I've done here, I've taken the time to go ahead and do all of the calculations again. So the highlighted calculation is the calculation for the standard deviation using a success probability of 0.8. That comes out to be about 1.8-ish. Now, if the success probability rises, so in this case, here is the standard deviation of the success probability rose to 0.9, so correspondingly the failure probability would be 0.1. Notice the standard deviation is lower, it's about 1.3. Again, if the graduation rate or the success probability rose even higher to, let's say, 0.99, again, correspondingly a failure rate of 0.01, the standard deviation continues to fall. It's all the way down to about 0.4. So the idea being here, as the likelihood of success increases, we expect to typically be closer to the true expected value. So the expected value can be found by taking 20 times 0.8, or as the success probability changes, 20 times 0.9 or 20 times 0.99, but as the variability drops. So as the likelihood of success increases, we expect more successes. We expect to be closer to the expected value, so that means the standard deviation, as we see here, has to drop. 1.8-ish to 1.3-ish to about 0.4-ish. And that's the relationship that I believe you were supposed to pick up on in part C.